Hi folks, Tim Sudol going over my demonstration video for embedded software at JHU, the 715 class. We're going to start off by explaining the project a little bit and showing my setup. I have my computer right here just to use it to SSH into the Pi. The Pi is the host machine, and the Arduino is doing all the temperature sensing. There's the Pi. Only connection is the USB over to the Arduino. Very simple wiring. It's just a 5-volt ground, and then the 2-pin is reading the data from the sensor. Now the software is, the architecture is set up like this. We start off by going through and doing all the initial setup, and the first interesting part is the interrupt service routine. Through here, since it's a 1 Hertz timer, I count to 10 to give it the 10-second between interrupts. Upon that, it checks to see which of the variable sets it should read, because I'm trying to protect the shared memory. Don't want to be reading the variable as it's being written to. Data gets corrupted, you spew out the wrong data. Nothing good. So it checks to see if it should read from the alpha or the beta set. It goes ahead and formats the elapsed time and the temperature, and then it spits it out over the serial bus. In this case, I'm just using the USB cable because it's longer. I have a 16-foot cable that I'm using. Makes it easy to move the sensor into the fridge when I need to, and it's a little bit more robust. My fridge has heavy doors and small jumper cables for the I2C. Might have had an issue with it. It was easier going USB in this case. The initial setup, part of the requirements were to check for stability before you begin recording the temperature. Well, in my case, I define stability as this 2.0 degrees between the current reading and the previous reading, just to make sure that we're getting a good reading and it's not fluctuating everywhere. After that, we suspend interrupts. We set up the interrupt timer. We are using the 1024 prescaler. And then after the timer is reset, we re-enable interrupts. After that, start the elapsed timer, the initial reading. Now this is where the round robin part of round robin with interrupts comes in. It's a very simple loop. It checks to see which variable set it should be writing to, and it writes that variable. As soon as it's done writing it, it flips the toggle so that next time through, it will write to the other set, and the interrupt will read the one that was just written. Fairly slow time sensor. It's a 2-second refresh. So at the end of the loop, I just delay for 2 seconds, because reading it any quicker than that would not do anybody any good. So that right there is the code running on the Arduino. And then over here, very simple code running on the Pi. It is just watching the serial bus, and when data comes in, it opens up the file, appends to the file, saves to the file. That way there won't be any open file handlers when you kill the program later on after you're done with your temperature readings. Very simple Python program here. It spits the data out to both the screen and to the file itself. You could see last time this temps file was written was at 8:29 a.m. this morning. Once I start running this program, it's going to erase that file and start it again as a brand new file. Let's go ahead and start it up. Since it takes 2 seconds to refresh, when you start the program, it has to initialize the temperature sensor, then it takes a reading, then it has to wait to take another reading to compare the two to make sure we have that stability set up that we were discussing earlier. Okay, you can see the timer is counting down. The next step is to move the temperature sensor into the refrigerator for a 5-minute time. However, before we do that, let's go ahead and do the calibration. I'm gonna shoot a IR temperature sensor at the temperature sensor, and it's giving me a 71.3 degrees. Now, the temperature is saying 78.7. That is going to be a difference of 2.5 degrees. That could just be because of the housing surrounding the temperature sensor. The IR beam isn't hitting the sensor directly. It's hitting the plastic surrounding it. So that could be the cause for the discrepancy. 2.5 degrees isn't anything to get overly excited about. With that, I'm gonna go ahead and pause the video and then move the sensor into the fridge. Here we see the Arduino with the temperature sensor nestled nicely among my leftovers. I'm gonna go ahead and close this up and go back to the program and see what the readings are saying. So we can see the temperature is starting to drop. The sensor is not the fastest. It typically drops around 0.5 degree per time step. It's just a function of how slow the sensor is. Eventually it will get down to the 37 degrees that the refrigerator is at. It would just take an exorbitant amount of time to get there. This project we leave in there for 5 minutes, so I will resume the video when we're ready to pull the Arduino out of the fridge. And we are picking the video back up in just about one more data burst. That's been about 5 minutes in the fridge. I am going to open the fridge and move the temperature sensor back to the counter. And we could see it right there, back on the counter. It did get down to 49.46 degrees. But now it is going to start climbing back up. As you can see, it's already up to 50 degrees. Now we're supposed to let it sit on the countertop for 5 minutes. I will be back when the time step is right around 8:27 to continue the video. And we are back and picking up the video with just about 10 seconds left before the 5-minute countdown with the temperature sensor being on the countertop at room temp is complete. Let's do one more tick and then we will go ahead and kill the program. Take a look at the size of the CSV file. You can see that it's 1,200 bytes, and just before 10 o'clock was the last time it was written to. Let's 6404 and 6440. Let's take a look at the tail end of the file and make sure that it is getting the correct data. And there you go. You can verify that it does in fact match up what was just previously on the screen. I'm going to go ahead and pause the video while I SFTP the file over and get set up in a graph so we could see what it looks like. And this graph is the end result of the experiment we just ran. You can see the elapsed time down at the bottom. I dropped the 2 decimal places just because it was more distracting than adding anything, but you could see it's just about 10 seconds all the way across the board. Based on the 0 stitch, it does skip values in between just because the data would be so crunched otherwise. Other than that, that concludes my demonstration on project 2. Thank you.